All right, as promised, this first topic is about solving equations and then discussing why our solution methods actually work anyway. Let's take a look back at our examples that I mentioned in the introduction. So here are our two equations, 5x equals 10 and 3x plus 6 equals 15. Some of the more basic equations that might have been discussed in Algebra 1. And just to refresh our memories, let's talk about what it means to solve an equation. Usually, what we mean by that is the phrase, I'm sure you've heard this before, it means solve for x or isolate the x. Get the x by itself. Isolate the x. Or in other words, solve for x. Anytime we have an equation, I shouldn't say anytime, but frequently when we have an equation, we have created that equation for the sake of solving it, meaning getting a numeric answer for x. So let's look at 5x equals 10. How do we solve an equation? Well, the rule goes, whatever I do to one side of the equation, I have to do to the other. And the goal should always be to get x by itself, or isolate the x, isolate the variable. So how could I get x to be by itself? Well, right now we have 5 times x. In order to get x by itself, I need to get rid of the 5. Well, 5 is being multiplied, so to get rid of it, I divide. Now, if this is like, whoa, way too much for just after summer, don't worry, we're going to talk more about this in a minute. But I'm going to do it quickly the first time through for those of you who remember. So I say, okay, I want to get rid of the 5, so I'm going to divide, because division gets rid of multiplication. Division undoes multiplication. But anything I do to the left side, I have to do it to the right side as well. So if I divide the left by 5, I have to divide the right by 5. And what does that leave me? Well, the 5's cancel, and I get an x, which is good, since our goal was to isolate the x, or to get the x by itself. And on the right, I get 10 divided by 5, which is 2. How do I know I've solved the equation? Because I have x equals a number. If I have x equals a number, then check, I have solved it. Okay, first example. I'm not going to take too much more time to explain it yet until we look at both examples. Over here on the right, I have another equation, 3x plus 6 equals 15. My goal is going to be the same in this second equation as it was in the first. We need to isolate the x, or get that x by itself. This time I have a little bit more going on next to the x. In fact, I have it being multiplied by a 3. I also have it adding 6 and then equals 15. So there's a lot going on. I want to start by, it's kind of like opening a present. I'm going to explain this actually. Let me switch back to my face so you can see me waving my hands in the air, because it's always easier to understand math when you can see hands waving in the air. Okay, when you open, have you ever seen those, like somebody decides that they're going to propose to their girlfriend, and so in order to make it a big surprise, they get this huge box, and then but inside there are like, I don't know, like 10 other boxes that get smaller and smaller and smaller, but every one of them is wrapped. And at the very center there's this tiny little ring box, and oh, the girlfriend opens it and she cries and says yes, and they live happily ever after, I guess. So, you've heard those stories before? I want you to picture that when we talk about equations. In order to get to the center box, the little one in the center, we have to start with the big box, the one that's furthest out. So we unwrap that big one, and then we get rid of that and we move to the second one. And we keep moving further towards the center as we get closer to the core, the important part that's in the middle. The same thing happens here. So look at our equation. I'll show you what I mean, how this relates. 3x plus 6 equals 15. Looking at the x, the 3 and the x, they're pretty close. They're like the inside package. And then we have plus 6. That's like the package on the outside. So we only have like 2 layers here. We have the 3x, that's really tight towards the inside, and then we have the plus 6, that's further out. So we unwrap starting with the furthest out piece. So plus 6, we want to get rid of the plus 6 first. So I'm going to say, in order to get rid of a positive 6, I need to subtract 6. But anything I do to the left, I have to do to the right. Subtract 6 on the left, subtract 6 on the right. So I get rid of these, they cancel, I get just 3x. If this is giving you a headache, don't worry, we're going to talk about it a little bit more. If you got it figured out, then you are probably good to go for our the rest of the lessons. 15 minus 6, that's going to leave us with 9. Am I done? No. How do I know? Because when I'm solving an equation, I should get x equals a number. Right now I don't have x equals a number, I have 3x equals a number, so I'm not done. It's kind of like that unwrap the present within a present within a present. We've done the first layer, but now we need to do the second layer. We need to get rid of this 3. 3 is being multiplied, so I undo multiplication with division. So we divide by 3. Whatever I do to the left, I have to do to the right. So what happens here? The 3's cancel and I get x, and 9 divided by 3 becomes just 3. And I now know I've solved the equation because I have x equals a number. In fact, here x equals 3. So check, I have solved the equation. All right, that is, take a look at that, let it sink in for a moment. That's the basic how we solve an equation in Algebra 1, and we're going to continue to do that in Algebra 2, although it'll get a little bit more interesting. I hope you think of it that way. But before we move on, I want to show, for those of you who it gives you a headache when you look at these different rules, because sometimes it seems like too random. I remember feeling that when I first took algebra back in the day, and I remember the first time somebody showed me how to solve an equation, I felt like they were just pulling things out of a hat. Like, oh, this time I decided to subtract. Oh, this time I decided to divide. Like, I understand the idea that you do the same thing to both sides, but how do I know which thing to do first? Where do we come up with these rules anyway? And if that's a question that you have, you're going to appreciate, I hope, this next video, this next topic, which will show us why these methods work. What's kind of the logic behind it all. So we will continue with the next video.